What is up, Multivariate gang? Got our last video of section 11.3. Let's go ahead and knock it out. Let's talk about orthogonal projections. All right. So you got two vectors. And we've got our, let's say a vector v. All right. And let's call them vector b. All right. Vector b. Doesn't matter how long b is. All right. And so we want to see, we want to find the components of v that are parallel and perpendicular to our vector b. And these are vector components. All right. So, first, the parallel component. We call that a projection of vector b on a vector v onto vector b. Essentially, the vector component of v that goes in the same direction as vector b. And we basically did this with orthogonal decomposition. We've just got to add an extra step. So if we had some unit vector, need a different color. We've got some unit vector, let's call them b hat. You know, this vector that goes in the exact same direction as our vector b. And b hat equals b over the norm of b. We're normalizing vector b. Okay. That's easy enough, right? It's the exact same as the orthogonal projection stuff. So we know that this vector is v dot b hat times b hat. Right? Easy enough. So all we have to do is we got to sub in this Joan for b hat. So we get v dot b all over the norm of b times b hat over the norm of b, which is equal to v dot b all over norm of b squared times the vector b. This is all a big scalar multiple of b. And that is the projection of v onto b. Cool. Easy enough. We know that is the projection of b onto v. Okay, now what about this piece? Well, we could try and find this unit vector, I guess, and do the same thing, but that's gross. We don't want to do that. And there's no reason for us to do that because we know something about this little vector right here. See, with this vector, we are drawing a vector from the head of the projection of v onto b to the head of vector v. So we know that this little piece is just vector v minus the projection of v onto b. Right? Because if you have the projection b onto v, and then you add this vector v minus the projection of v onto b, you just get vector v. Yeah. So to find these two components, we just gotta make this calculation for our projection and then subtract the vector we find from v to find the perpendicular component. Maybe it'll make a little more sense with example problem. Let's go. All right. Find the vector components of v parallel and perpendicular to b if v equals 5, 12 and b equals 3, -4. All right, and we're going to keep it two-dimensional for now, just to keep it simple, but this worked for three-dimensional stuff as well. Okay. We know that the projection of V onto B is, follow a little formula up there, V dot B over the norm of B squared times our unit vector, or times the vector B, not a unit vector, times the vector B. Let's find this part first. So we know that our V dot B, we know that's 5 times 3 plus 4 plus 12 times negative 4. So write that down, 5 times 3 plus 12 times negative 4. That's 15 minus 48. Negative 33. Easy money. All right. The norm of B. As you can probably guess, it's 5. I absolutely did that on purpose. Norm of B equals 5. It's a 3, 4, 5 triangle, Pythagorean triple. All right. So we know that that's negative 33 over norm of B squared, which is 25 times our vector B, 3, negative 4. And that gives us negative 99 over 25 plus 33 times 4 is 132. Yeah. 132 over 25. Beautiful. Okay. And so then our perpendicular component is V minus projection of V onto B, which is equal to 512 minus negative 99 over 25, 132 over 25, which gives us which is 125 minus 99. Nope, plus 99 over 25. Then what is 12 times 25? That's 300. 300 minus 132 over 25, which gives us 224 over 25 times 168, not times 168, 168 over 25. That is our perpendicular component, parallel component, perpendicular component. I'm going to go ahead and check my math. Okay, that's good. That's good. Sweet. Okay, that's all there is to it. And you guys actually will use this formula, use these projections for some other stuff you do later in the chapter. So take note. Nota bene, as they say. Cool. Congrats on finishing this section, guys. I hope you all have a fantastic